Hi girls. I want to give you a little conclusion from today. So before today, we were just focusing on this part. Let me highlight this part. We were just focusing on this part before today. So you're comfortable of changing moles of a compound to mass of that compound using molar mass, right? Grams per mole or mole per gram, right? It's grams per 1 mole or 1 mole per how many gram. This is the molar mass, right? And then once you know the mole, you can go to formula unit or how many number of molecules, numbers of compound, right? Using the Avogadro's number. It's 1 mole is equal to 6.022 times 10 to the 23rd power, right? That's before today. But today, what we learned is this one. We learned the mole ratio. So now we extended the bridge from just the compound itself. Now I can find a specific element within that compound. Remember the example we did today was the ion 3 carbonate, right? So if I know the number of mole of my whole compound, I can find number of mole of oxygen, carbon, ion, right? Everything in this compound. And by using mole ratio. And when you think about mole ratio, think about how you calculate molar mass, right? In 1 mole of the compound, you have 2 mole of ions, you have 3 mole of carbon, you have 3 times 3, you have 9 mole of oxygen. This is your mole ratio. And we use them the same way that we calculate molar mass, okay? And then once you know mole of element, you're able to do the same thing. Use the molar mass of the element to find the mass, or you can use the Avogadro number to find number of atoms, number of element, or it's also called the formula unit, right? So that's what we did today. So let me show you the answers for the problems. So if you have this many grams of aluminum carbonate, right, you have to write the right formula. Aluminum has 3 plus charge, carbonate has 2 minus. To balance the charge, your formula needs to be Al2CO3 3. Okay, and you will be able to calculate the molar mass using the right formula. So you will start with given 10.0 gram, and then you know gram needs to go on the bottom, right? And this is your molar mass of this aluminum carbonate. And then mole needs to cancel with mole, and then use the Avogadro number to get the final formula unit, number of formula unit. And then it asks you how many moles of aluminum, right? Not the whole thing, of aluminum. If you have 1 mole of aluminum carbonate. So if you look here, so basically it tells you you have 1 mole of aluminum carbonate. And it is asking for mole of just, mole of what? Mole of aluminum up here. Ask for mole of an element. So you need to use what? The mole ratio. So you start with given, right? And then you need to put exactly the same thing down here because you want to cancel them, right? So you know you have 1 mole of aluminum carbonate. And based on the formula, you see that you have 2 aluminum. So you need 2 mole of that. This is your mole ratio. And then when you calculate, you get 2 mole of aluminum. I know, this looks easy. But then when you get some numbers, okay. So now you know you have 10 grams of the whole thing. And it's asking how many atoms of oxygen, right? So number of formula unit of oxygen. So from 10.0 gram of the whole thing, of the compound, you can get to how many mole of the compound, right? Right here is mole of compound. So you need the mole of compound down here to cancel out, and then you're looking for mole of oxygen. So 9 mole of mole of oxygen go on here, and you have 9 mole because of the formula, right? You know for every 1 mole of compound, you have 9 mole of oxygen. So here you end with your number of mole of oxygen. But it's asking you how many atoms. So you have to go from mole to number of formula unit or atoms using Avogadro number. So this is your final answer. And then what is the mole ratio of oxygen in aluminum carbonate, right? We see in aluminum carbonate, so 3 of the carbonate, right? That means you have 3 of carbon and 3 times 3 of oxygen. So this is 9 oxygen. Next one. So it gives you number of molecules of barium nitrate, right? You need the right formula. And then from this molecule, you need to go to mole of this molecule. And then you have 1 mole and to the molar mass of the molecule. And then how many moles of barium nitrate do you have? So this, you can also go from this number of molecule using the Avogadro number to get to mole. And then it asks you how many mole of oxygen, right? So you know you have total of this many mole of molecule. So you need to use the mole ratio. So you will copy down the mole of the compound down here. For 1 mole of this, we know that we have 9 mole of oxygen. And then you have the right number of Sigfig. And then it's asking what's the mass of oxygen, right? If you know you have this many mole of oxygen, for 1 mole, you have this many grams of oxygen. So you get that many grams of oxygen. Thank you.